Hi, my name is Charlie Majorana, and I'm an artist working in rural Maryland. My great joy in life is learning about new materials and techniques and giving them a try. I'm also the author of the book Puttering Around the Art Studio, which contains a lot of my best ideas and techniques. It's available through Amazon if you'd like to pick up a copy, and I've included a link below the video. You might have seen wave patterns made from either plywood or from laminated stacks of solid materials and wondered just how they were made. When I first came across them, I certainly wondered. Because there is very little information available about how folks are actually making these, I decided to play around, and what I'm presenting here is the technique that I use. In this video, I'll go over exactly the steps necessary to make panels such as these. The first thing to realize is that panels such as these are carved using a CNC router. They are not carved by hand. These machines are becoming common in woodworking shops and are found in most maker spaces. Even if you don't own a CNC router yourself, you can usually find access to one. I live in a very rural area, and even here I know of 3 other CNC routers besides my own within 20 miles of where I live. First, let's talk about the possible types of materials for these kinds of laminated panels. To achieve interesting designs, you need to use a build-up lamination with some kind of contrast between each layer. The materials that I've experimented with for these types of panels are plywood, both standard and Baltic birch, solid wood using contrasting types of wood in each layer, colored MDF sheets, and colored expanded PVC sheets. Laminations of plywood have the huge advantages of cost and availability. If you are just giving this technique a try, I strongly recommend learning and making your mistakes using plywood before you invest in the other options. The other material choices are not cheap, and the process can require many hours of cutting on a CNC router. When using plywood, you are taking advantage of the glue lines and different orientation of the layers to give you the contrast that makes these panels pop. Because of voids in the layers and the softwoods used to make the plies, the resulting panels made from these laminations have a rustic quality. Baltic birch plywood is made with very thin, uniform plies and has a void-free core, so your panels will have a very different appearance than if you use standard plywood. Depending on where you live, you might have to buy it online, and it is much more expensive than regular plywood. Rockler Woodworking is one online source. Now don't confuse the common birch plywood that you find in home improvement stores with Baltic birch plywood. Common birch plywood is just regular plywood with the outer laminations being birched. It is not the same. If you are interested in making your laminate block using solid wood, you'll need to find a source for thin wood boards of contrasting species, and you'll probably need to order the wood online. If you search for scroll saw lumber online, you'll find a couple of suppliers, and I've listed these in the description below. Rockler Woodworking also sells a selection. Colored MDF is made by Velcromat and Geotone. This material is simply a high-density MDF with colorant added during its manufacture. It is not cheap and it is a little harder to find than the other materials, but a source that I've used is Trinity Innovations in California. A link is included in the description below. I strongly recommend buying their sample packs of colored MDF before investing in larger sheets. The most colorful material to use for your laminations is expanded PVC, which is available in a variety of thicknesses and colors and is also known as foamed PVC. The most common brand of this material are the Pallite sheets made by Pelram. This material is heavily used in the sign industry, and plastics suppliers such as Acme Plastics are a good source, as well as a few colors and sizes being sold through Amazon and home improvement stores. I've used all of these types of materials, and my preference is using expanded PVC. The colors are bright and it machines really well. I assume that anyone watching this video would be able to make a plywood or an MDF laminate, but if you're interested in PVC, I suggest you check out my companion video called How to Make a PVC Laminate Block. Now, the theory behind creating these kinds of panels is actually very simple, and it amounts to exploiting the ability of CNC software to interpret white pixels in a drawing as the very high spots in a model, and black pixels as the very lowest spots in a model, and setting the height of any gray pixels proportioned to the darkness. Now, I'm using Aspire software with my CNC router, which does have this ability. If you had an image that consisted of just black and white areas, after machining, the edges between these areas would be interpreted as being vertical. In order to have smooth transition between these areas, which you'll need for the type of wave patterns I'm discussing, you need to have a gradation of gray between them. So the technique that I'm using to achieve the gradations that I need is really very simple. I'm starting with a black and white drawing and then applying a blurring filter to the black and white drawing. Now, blurring is a common operation in almost any photo editing software. I happen to be using Affinity Photo, but all photo processing software has a similar capability. There's a number of different blurring options that you'll be presented with in almost any photo editing software, and the simplest to use and understand is called Gaussian blur. And that's the one I'll be using in the demo that I'm going to be doing in a few minutes. But some of the other blurring techniques can give you very interesting results, such as the motion blur. So in summary, the workflow that I'm following to create these panels is to first create a black and white drawing, second, to blur the drawing in a photo editing program, third, convert the blurred drawing into CNC instructions using CNC software, and fourth, simply cut the panels on my CNC router. Before I get into the demo, here are 4 simple drawings and simulations of the panels each would produce. Unfortunately, the software that I use simulates only a solid color display option. Because the contrasting layers are one of the main visual features of the panels, you'll need to use your imagination a bit. For each of these 4 samples, the sequence of images are: first, the black and white drawing; second, what that drawing would look like when machined; third, the drawing blurred; and finally, what the blurred drawing would look like when machined. When creating the artwork, almost anything you can come up with will work. Having an image that is roughly half black and half white seems to be a good starting point. I use the Easy Draw drawing program, which has a lot of built-in configurable stellate options, as well as the ability to generate stepwise blends between 2 figures. If you need inspiration, just look through one of the Dover Op Art and Geometrical Image collections. Now, the first step in the process is to draw a black and white image of some sort. And this is the image that I originally was going to use. It would have produced a pattern art that would look approximately like what you see here. The problem with this image is that it's very similar to patterns that I've made before, and I wanted to do something a little different. So here's the image I've decided to use for the demo. It's basically my redrawing a piece of an image that I found. What is hard to see on the screen is that there's a 1/2 inch black margin all the way around it. Now, because this video is not about creating drawings, I'm going to start the demo assuming that this drawing already exists. So here I brought the image into Affinity Photo so that I can access its Gaussian blur function. So I've selected the photo and I'm applying a Gaussian blur filter. It's way too much blur. I'm backing it off to about somewhere around there. Here I'm using about a 17 pixel blur radius. Applying that. And then I'm going to export it as a JPEG. And here's the blurred image that I'll be using in the next process. So the last step at the computer is to convert the blurred image into instructions for the CNC router. Here I've opened up Aspire and I'm creating a new project. And the job size is 11.625 inches by 11.625 inches, and the block I'll be machining is just under 2 inches thick. It's important that the Z0 position, your reference point, be the machine bed, because if you had it the material surface, you'd lose your reference point once you'd machine down the surface. It doesn't make any difference what material you pick, since Aspire does not have the ability to show you a layered material. Having created the job, I'm now going to open the Modeling tab and bring in my bitmap and create a component from it. Now my bitmap is named Demo Scan Blurred, and let's see, it's actually just on the desktop. There it is right there. Opened it up. Now, because the image was 12 inches by 12 inches and the job is slightly less than 12 inches, I'll need to center it or else it'll be offset a little bit. So I'm going to select the component and center it. Now I'm ready to generate the machine instructions. So I'm going to I'm going to go over to the Toolpaths tab, and the first thing I want to do is set up the material. Now, if I were to cut this right now, it would be a very thin, about a 1/4 inch thick piece. I want to scale the 3D in the Z direction, and I also want to position it within the material. And so I come over here to set, and I'm going to set a height of about 1.7 inches. And you might have noticed over here that the model has been positioned in the material, has changed. But I actually wanted to move it up a little bit, and so here I just want to skim off just a little bit off the top, and I'm keeping about 0.19 inches material at the bottom, which should be plenty. Now I'm ready to create my two tool paths. I'm going to first create a roughing tool path using a 1/4 inch end mill, and I'll call this my 3D roughing path. I'll then create a finishing tool path for a 1/8 inch ball nose, and I'll call this 3D finish. Once the tool paths are calculated, I'll then preview the tool paths to see what it looks like. And see what it looks like in 3D especially. And that looks kind of interesting to me. I'm going to do it. So I want to save my tool paths. Oh, before I do that, I'd like to check and see how long it's going to take to actually cut this particular model. And it'll take me about, let's see, about 5 hours, which always seems like a lot of time, but it does a nice job. So I'm now ready to save my tool paths. I should have had this selected here. So now I have my 2 tool paths saved. I'm simply going to copy them to a thumb drive and the next step is just take them to my CNC router and cut the model. So here I've loaded up my panel on the CNC router, and it's starting to cut the rough pass with the end mill. Now I'm taking off about 1/4 of an inch in each pass, and since there are about 7 layers, it'll be 7 passes, so it takes quite a while to do this. Now you'll notice that I'm using a hand vacuum to kind of help out. My shop vacuum isn't quite strong enough to do this by itself. I'm going to let this video run for just a little over 1 pass, and then I'll turn it off and I'll show you what the rough pass looks like when it's done. I don't consider myself an expert of any kind on the CNC router, and I'm always a little dubious of the feed speed and all the speed settings. PVC is actually very easy to cut. It doesn't really chip, it kind of disintegrates. And sometimes if you go too slow, it kind of sticks together. And so I'm going fairly fast, but I think I still could actually run it up a little faster. And maybe the next time I give one of these a try, I'll run it a little faster. So here's the completed panel after the roughing pass. If you look in the far right corner, you'll see I have a small little chip out, and that I'll probably end up having to repair by hand. And this is because I was testing using gluing only on one surface, and I definitely will go back to using gluing on both surfaces. So I've switched bits, and now I'm on to the finishing pass. Now the finishing pass is just 1 pass over the entire area, but the overlap is very small, and so it takes a fair amount of time. So here's the completed panel, both looking straight down on it and at a angle. Now if you try to do this with PVC, be sure you don't sand it. If you sand it, the blue and the white will mix and you'll never get the particles out. I use just a stiff brush all over it. How I've been mounting the panels is in a shadow box frame and I think that it enhances the 3D quality of it. Within the frame, the panel is raised up about 1/2 inch off the back, as you can see in this close-up. I hope you enjoyed the video and that it was instructive for you. If you did enjoy it, be sure to give me a thumbs up. Also, I plan to post a number of videos in the future, and if you'd like to be notified when a new video is posted, just be sure to subscribe.